Hi everyone, hope you guys doing good today. Today I'm going to continue my lecture 8, chapter 8. Today I do chapter 8.3. Still we are in confidence interval section for one population mean. In this case, sigma is unknown. Okay, if you remember chapter 8.2, we discussed the situation like when sigma is known, but now sigma is unknown. When sigma is unknown, we cannot use C table. We cannot use that one. Okay, because sigma unknown, sigma unknown. So we cannot use C table. Simply, we cannot deal with C score. So to overcome this case, we introduce another table we call T table. T table. I know some of you have heard about this T table. Some of you haven't seen this guy before. Anyway, uh, for now onwards, we use T table or T values. Okay, why we use this T table? Because we don't know sigma. Okay, I have given some kind of introduction of this T table. What is this T, the history of this T table? So please check this. Okay, we call this T table studentized version of the sample mean, because normally we call this T table or T value studentized T value, standardized T table, something like that. Okay, so that's why standardized version of the sample mean. Okay, not standardized. Standardized case we have done last time 8.2, but here since we don't know sigma, we have to use standardized version. Okay, suppose that our variable x as a population is normally distributed. Okay, with mean mu, then sample size n. You can calculate this t value like this. Do you remember how we calculated standard value c value? C equal x bar minus mu divided by sigma, right? But in our case, we don't know this guy, right? We don't know sigma. So that's why we just eliminate this guy using this s over square root of n. This s is the standard deviation of sample. Do you remember that? Standard deviation of sample. Okay. So instead of c, you have to calculate t using this formula. So this t distribution it's not exactly like C, but it's like C table. Okay, it's like C, not table, it's like C. With T distribution, we have to discuss something like degrees of freedom. Degrees of freedom. So always remember that degrees of freedom, simply we mention it simple D, simple F, degree of freedom. It is n minus 1. It's always n minus 1. Remember this one. S is the sample standard deviation. Okay. Okay. This is something I have mentioned here: standard normal curve and T curve. See this this standard normal curve is the green color one. Okay, green color one is the standard normal curve, and there are two T curves: red color one and blue color one. See this red color one and blue color curves. They differ from each other due to their degree of freedoms. Here degree of freedom is 1, here degree of freedom is 6. So although you have same value, but it changes according to the degree of freedom in this t table. Okay, but they looks like, see they this one, they look like same, right? this C curve, the red color one, sorry, green color one and the red color one. See, they are they are very close to each other. Okay, okay. There are few properties you should know when we are using T curve. First one, total area under the T curve is equals to 1, same as C curve. Okay, same as standard normal curve. Okay, T curve extends indefinitely in both directions, negative infinity, positive infinity, same as C curve. Okay, T curve is symmetric about 0, yes, same as C curve. Number of degree of freedom become larger when which mean degree of freedom goes up, it closes to standard normal curve. Okay, curve increases like the standard normal curve. Okay, confidence interval using this standardized t values. How we do it? Using this formula. Only difference is this one. See, they looks like very same to each other what we have used in chapter 8.2. Okay, we use very similar one, but here instead of c we have to use t, same as t alpha over 2, but in this case this t table, it works with degree of freedom. This is your degree of freedom. Okay, so you cannot find any value by just using alpha over 2. You have to use degree of freedom as well. I'll show you how to use that. So right now just focus on this formula. Okay, this s you can calculate by using given data. Okay, it is the standard deviation, so you know how to calculate that. Okay, in chapter 5 we did this, chapter no not 5, chapter 3 we did this, or chapter 6 we did this. This is square root of n, which mean me sample size. Okay, so as I mentioned, this t alpha over 2 comma degree of freedom, which mean n minus 1, can be founded on the t table. You can find the t table, which mean table 4 in page A6 and A7 in your textbook. Okay, okay, n minus 1 is degree of freedom, remember that. Okay, uh still same as chapter 8.2, what we have done, we have 3 steps to find confidence interval. Confidence interval of 1 minus alpha, this is what we need to find, using this time using table 4, which mean t table. Okay, this time t table, t alpha over 2 with degree of freedom n minus 1, n is the sample size. How you find the confidence interval for mu? Using this x bar minus this part. Do you remember this part? T alpha over 2 comma n minus 1. This is degree of freedom. This is degree of freedom times s over square root of n. 2 x bar plus this part, that interval. Okay, t alpha you can find using step 1. So plug those values, you can get this at the end, interpret the result. Okay, let's see how we find the t alpha. In this t table, come here, this is the general outlook of t table. Okay, you can see your degree of freedoms in your left hand side. This first column or sometime last column is a degree of freedom. This should be n minus 1. Okay, this should be n minus 1, don't forget it. This column represent these columns represent t values. See, t alpha, t t alpha, let's say alpha equals 0.5, 0.05, See this one, T 0.05, which means this guy. You can see there are so many values for T 0.05 based on different degree of freedom values. In this case, what is the degree of freedom? Okay, I have this example. Assume that degree of freedom is 4, okay, which means n equals 5, then my degree of freedom equals 4. So you have to locate this line because degree of freedom is 4 here, right? What is my alpha? 0.05. So now I need to find t uh, sorry t 0.05 comma 4 degree of freedom. So degree of freedom this line and t 0.05 this line. Now you can find the cross line, the intersection. This is your value, yellow colored value 2.132. This is your t value based on 0.05. Okay, this is how you're going to, this is how you find the value using t table. Okay, you must know what's the degree of freedom. Don't forget degree of freedom equals to n minus 1. N minus 1. Okay, okay, let's see this example. I'm not going to through this explanation. Use the data to find 95 confidence interval for mean loss mu. 95 confidence interval. Okay, so 95 confidence interval mean you can find confidence level. It is 0.95. Okay, you can calculate alpha 1 minus CL, right? Okay, uh, there are how many? This side 1, 2, 3, 4, 5. There are 25, right? N equals to 25. Okay, let's see. Step 1. Confidence interval for alpha interval of 1 minus alpha using t table. Okay, t table. Using t table, you can calculate t alpha over 2. Degree of freedom in minus 1. What is it? You know what is it. N is 25. Okay, 95 confidence interval. So alpha is 1 minus confidence level 0.05. So you know what is n. Degree of freedom is n minus 1, which means 24. So you can calculate t 0.05 divide by 2, don't forget this, comma degree of freedom 24. This value from your t table. Degree of freedom from this side, t values from this side, and you can get this value. It is your value 2.064. Okay, clear? Okay, so you know this guy now. Again, this guy. So only thing you have to know what is the x bar, and please calculate s. I think they haven't mentioned s. So now we can calculate. You know this one. Applying the usual formulas for x bar and s. Find those values. X bar is this one. S is this one. Okay. You can find these formulas for x bar and s from your formula sheet. Now you can conclude that 95 confidence interval for mu is from these two values. Okay. Only new thing is to find these guys. Okay. Okay. How do we interpret that? You know these are the values 405, 621. So you can interpret that we are 95% confident that the mean loss of all pickpocket offences is somewhere between these two values. Okay, this is easy. Only thing is you need to figure it out how to find T alpha over 2 comma degree of freedom, that value from the table. Please go through the T table and try to understand how to find a value using T table. Okay, okay guys, then that's it for today. Stay safe. See you.